يا شباب no can someone record كويس. طيب بسم الله. Now يا شباب I said نحن in the last lesson I divide this to divide the base resistance. You also have to remember that it's proportional to voltage. So if you can change your resistance, you can change the voltage. An example of that is an LDR. An LDR. What does an LDR stand for? An LDR is a light dependent resistor. And that's the symbol, light dependent has to be correct. Normal resistor. So this thing, it can change its resistance based on light. How? If there is light, the resistance of this thing is low. Means if it is dark, the resistance is going to be high. As simple as that. So the fact that this thing can change its resistance means it can also change voltage. You can also change voltage across it. So by itself, we cannot use it as a potential divider by itself. But when we connect it in a circuit, with something like, let's say, a fixed resistor. So there's a fixed resistor here, and then you have your LDR here. So now this circuit can be, we can say this is the fixed resistor. And this is your LDR. And let's say this is 48 volts. Now, assuming we have two voltmeters on here. Voltmeter 1, which measures the voltage across the resistor. Have voltmeter 2, V2, that measures the volt LDR, so that we can see if actually voltage is being divided. طيب فارس, V1 plus V2 شنو? What will be V1 plus V2? Always.
التوتال فولتج اللي هي 48.
Why?
واي شنو؟ ليه 48 يعني؟ يعني
I said give you what? Being this simple. So if this guy is gonna take 40 volts. That is my voice hanging? Huh? فارس.
يا مستر.
سامعني كويس؟
سامعك كويس هاي.
So I said this thing is a variable. The voltage will be shared because they're in a series circuit. طيب. Now let's مثلا try to see what will happen if you are told state and explain what will happen if the room gets brighter. So we are saying you have to write it as a sequence of events. If the room gets brighter, it will cause the LDR to have low or high resistance?
Low.
Yeah, to have Now this will cause the voltage across the LDR. The voltage this will cause the voltage across the LDR to also be low. Now the voltage across the LDR to be low will cause the voltage across the fixed resistor to be high. لأنه they are always sharing. It means if this guy takes a small voltage, this one is going to take the remaining high voltage. Okay? They are always sharing voltage. You have to know that. So you have to always explain it as a sequence. The brightness causes the LDR to have a low resistance. It causes the LDR to have a low resistance. The low resistance means it's going to take low voltage, and these two things are proportional to each other. And if this guy takes low voltage, then this guy is automatically gonna take the high voltage, and because they are in series, they will always share. We said always V1 plus V2 is always 48, because these guys are in series. Another thing I want you to keep in mind is this: when you're answering questions of this kind, you always have to learn how to state your observation. يعني مثلا you write, if I was answering this question, this is an explanation, but the question will always be interested in the observation. So if I was to write an observation, I would have something like this. I would have V2 reading decreases while V1 increases. So this is a typical observation. And then this sequence of events will be now the explanation. في زول عنده سؤال؟
No.
لا مستر.
طيب let me so this is a basic question. So you'll be asked, how does an LDR work as a potential divider? We say it works as a potential divider if you use it together with another fixed resistor. It can divide the voltage based on this. When there is light, the resistance is low. I'm sorry, I wrote LEDs here. I'm supposed to write thermistors. A special site. So let's talk about a thermistor. Now, what's the thermistor? Faris, thermistor. Wissam, what's the thermistor? What did I say a thermistor is? Wissam, thermistor. Wissam, what's the thermistor? Dua Ayman, what's the thermistor?
Heat-dependent resistor.
A heat-dependent resistor, very good. So basically, this is a heat-dependent resistor. Type. The symbol, very important. The symbol for a thermistor is something like this. So this thing depends on heat. How? If there is heat, again, the resistance is low. Low resistance. If it's called a heat-dependent resistor, then if there is heat, the resistance is low. Same thing, LDR. If there is light, the resistance is low. It means if it is cold, the resistance of this thing will be high. It will have high resistance. So these are basic stuff that you're supposed to know about a thermistor. A thermistor is a resistor that changes its resistance based on heat. If there's a lot of heat, then the resistance is low. If there's little heat, then the resistance is high. Again, how can it work as a potential divider? The fact that it can change its resistance. If you can change your resistance, then you can change your voltage. And these two things are proportional to each other. If your resistance can change, then your voltage can change. So since the resistance here is changing based on heat, then we can say this thing can be used as a potential divider. It can be used as a potential divider. Type how? Again, you have to understand how it works in a circuit. So that's our circuit here. Let's say it is 8 volts. Now this time you are given not voltmeters. Let's assume these are 2 bulbs. This is lamp 1. This is connected in parallel with this guy here. And this is lamp 2, which is connected in parallel with this other guy. You are told set and explain what happens. So set and explain what happens. To the brightness of the lamp. As the temperature falls or it gets colder. So if you don't know, you have to know, you have to first understand before we answer the question. You have to understand that the brightness of any lamp is always affected by the voltage. The voltage is equal to brightness. You have to keep this somewhere in your mind. So if there's a lot of voltage in a lamp, it becomes bright. If there's less voltage, it becomes less bright. You have to keep this in your mind. So set and explain what happens to the brightness. So Wissam, I don't know why Wissam is not replying. Wissam. وسام ما قاعدة؟ طلعت. طيب يا دعاء اشرحي لي بيحصل. دعاء أيمن.
نعم.
طيب what happens?
The resistance of a one ما عارفة يا مستر خلاص طشيت.
لا أنت وريني الأوبزرفيشن أول حاجة.
The brightness of a one will increase. While 2 will decrease عشان الريزستور حق ال1 حيبقى عالي والفولتج حيبقى عالي والعكس.
Okay, that's nice. Now, Dua says the brightness of L1 will increase and the brightness of L2 will increase. But we want to explain what? We want to explain that. So we are saying when you have to explain it as a sequence of events in your explanation, you have to explain it as a sequence of events. You start with the temperature falling. So you say when the temperature falls, what happens to the resistance of the thermistor? It becomes what?
Increases.
Yeah, it increases. That's the first thing that will happen. So the resistance increases, and since resistance is directly proportional to voltage, we say the voltage of the thermistor also does what?
Increases.
Increases. So what will happen to the voltage of the fixed resistor?
Decrease.
Decreases. Now, a better way of saying it decreases is saying it gets a smaller share of the voltage. It gets smaller share. That's a better way of saying it decreases. يعني مثلا, because it's like you're bringing the idea of, okay, these two guys are in series and they will always share the voltage. And if the thermistor's voltage increases, then the fixed resistor is going to take the smaller share. And then you say, because of this, L1's voltage increases because it is in parallel with thermistor. So because of this, it is bright. You don't need to mention that voltage affects brightness. You don't need to mention that. You just need to say it becomes brighter because the voltage increases. So that's the sequence of events. Renard. Yusuf. Yusuf. Yeah, Renard.
السلام عليكم.
Alaikum salam wa rahmatullahi wa barakatuh. How long have you been waiting?
Like 10 minutes.
لا حول ولا قوة. Sorry. طيب نحن meanwhile وطبعا الحمد لله the lesson is recorded so everybody can now watch يعني بعدين. So the thing here is يا شباب, we have 3 different circuits of potential dividers. We have the first potential that we discussed. Which can also be used as potential dividers, and you should learn how they work in a circuit. So those are the special components that we are supposed to have discussed. LDR, a thermistor, and a light dependent resistor. And the potential divider, sorry, the typical potential divider. So let's go to a diode. Now a diode is not a potential divider, it's just part of the special circuits. Remember in our outline, we have diodes here. We are done with LDR, we are done with this, we are done with this. Someone's asking a question.
لازم تكون في series.
The resistance, yeah, for them to work as a potential, what's this? For them to work as a potential divider, they have to be in series. Okay? يا شباب, a diode. What's a diode?
ده اللي هو يا مستر بخلي الكارنت انه يمشي in one direction.
Yeah, it's a device that only allows
A rectifier.
current
لا ما في شنو؟
go in one direction.
هو دخلنا قال لنا يا جماعه ما يجلس تسمعوا ثاني لانه انا حسجل المسجد بس قال كده حسجل الريكورد يعني ما مشكله لو عندكم حاجه كده ما بتفرق. انا قال حدخل الحصص في اي وقت.
يا يوسف المايك بس اقفل يعني.
طيب, a device that allows current to flow in one direction is what we call a diode. A device that allows current to flow in one direction. The symbol for a diode is this. And it allows current to flow in the direction of its arrow. In this case, the arrow is facing this way. it will only allow current to flow in this direction. And the current we're talking about here is conventional current. Yeah, Faris.
يا مستر.
What is conventional current?
ما عارف والله.
Who can tell me what current is?
دي اللي هي مستر one direction لل negative لل positive.
Conventional current is the current that flows from positive to negative. It's the default direction for current. Electron current is the actual movement of electrons, actual flow of electrons, which is always from negative to positive.
مستر
So when
وسام
I'm
قالت
saying
لك
this
دخيلة.
thing will only allow current in this direction, then I'm talking. So when I'm talking about conventional current, I'm talking of current where this is positive and this is negative. So if the current is flowing in this direction, then the current will flow. Now in this case, we say, يعني مثلا look at this. طبعا this is a battery and this is a positive and this negative. And let's say this is a lamp. And this is our diode here. This diode is said to be forward biased. What does it mean to be forward biased? It means the current, it has been connected in such a way so we are saying the current flows from positive. Since the diode is facing this direction, the current will be allowed to flow. So we say it has been forward biased. We say the diode is forward biased. The diode is biased. Type. The other one is said to be reverse biased. So a diode is said to be reverse biased if it is connected in such a way that current cannot flow. When it is connected in such a way that current cannot flow. Like the flow of current is blocked. So this is an example. Let's assume these are positive and these are negative here, negative, positive. And you bring your diode and you connect it like this. This bulb will not light. Unlike this one here, which will work. This one will not. Why? If you follow the flow of current, the current is going in this direction, from positive to negative. But the diode is opposite. The direction of the diode is opposite. So it will not allow. At this point, it will not allow current to flow. So we say, when it is connected like this, we say the diode is reverse biased. So a diode is a device that only allows current to flow in one direction. It has two modes of connection. It is either forward biased or reverse biased. Type. What is forward biased? It means it has been connected in such a way that the current can flow. What is reverse biased? It means the diode has been connected in such a way that current cannot flow.
مستر.
طيب. Yes.
طيب الفايدة شنو من الريفيرس بايس؟
You will see it is used in rectifier circuits. Faris is asking what's the importance of now reverse bias? Why would I even connect it like this? So it is used in rectifier circuits. Rinad, what's a rectifier circuit?
دي بيكون فيها 4 diodes. It's used to convert from AC to DC.
Very good. It converts AC to DC. A rectifier circuit is a circuit that converts AC to DC. A rectifier circuit converts AC to DC. Now, let me try to share a circuit thanks to Rinad. Now, this is an example of a rectifier circuit. Now, for those who don't know, this is how an AC looks like. AC means the current is always changing. We studied this in Kida. So this is current. This is positive and this is negative. The current keeps changing from positive and then it starts flowing negative. Here it's flowing from positive to negative, but when it reaches here, it is flowing from negative back to positive again. It keeps changing. That's what we call AC current. But direct current looks like this. It doesn't change. Direct current mostly looks like this. It's always on the positive side. So if this is 10 volts, this is minus 10 volts. But this is 10 volts. Now the minus here means direction. A generator produces current in such a way that it changes direction. So can you look at this circuit? This is the symbol for the AC, meaning this thing is producing AC. You want to change this AC to DC. And then I want you to draw this. This is from one of the exams. Actually, a very early exam. This is a motor. So this is called a rectifier circuit. Can you draw it first? This is me. As a student simply this after because I didn't teach this after that. طيب يا شباب. Ryan, am I sharing my screen?
مستر ما صعبة.
دقيقة بس. طيب. How does this circuit work? Now, I want you to understand this curve first. You have to understand that this is how AC looks like. When someone tells you I'm producing AC, you have to know it means 10 volts AC means you are moving from 0 to 10 volts maximum in a specific direction from positive to negative. You are still in the positive side. And then it changes again from negative to positive, as if this one is changing. So the current keeps changing direction. Every half cycle, it changes direction. Every half cycle, it changes direction. So let's assume the current currently is flowing in this direction from positive to negative. Let's assume this is my positive and that's my negative here. So this is how the current will flow. The current always flows from positive. It will pass through this diode, okay? It will pass through the motor. Now I want you to realize how the current is flowing down. I want you to see how the current is flowing down. It will pass through the motor, come back using this normal path. So it means current will flow in the motor in this direction. So that's from positive to killer. That's the first part. Type. What if the current now changes direction? What will happen in the second half? What will happen in this other half? So we are saying in this other half, the current flows from positive to negative and the poles change. The current flows in the opposite direction. So it's like this becomes our positive and this becomes negative. Every half turn, it changes. This becomes positive, this negative, this negative, this positive. They keep changing. That's how AC is. It changes direction. So in the other half, when the current wants to change direction, this is the first half. The current was flowing in this direction. In the second half, the current will flow like this. It will flow from positive. Now, can it pass through this diode? Faris, can it pass through this diode?
لا لا.
Ayan, can it pass through this diode? Why? We say it is reverse bias. So we are saying it will not flow through this. So instead, it will look for another path, which is now through this diode. It will go through this diode like this, up, and then it will pass through this thing, down again. Look at the direction of the current. It's passing down. So even in the second half, it is passing down. It is flowing in the same direction. Even though the direction on this side has changed, the direction in the motor has not changed. So positive like this, like this, like this, like this, it flows down. When it comes like this, it goes using the other path to the negative. It cannot go through the path that it came from. It will not go like this. It cannot go like this. Current cannot take the same path. If it is using this path to come in, then it will use this path to go out, another wire. So again, our current is flowing from positive to negative. Now, in this case, this will be the current again in the motor. The current in the motor is still flowing in the same direction, but it is still moving from 0 to maximum to 0. And this will continue like this. It will continue like this as long as this is called rectification. Now, this is DC. But is not smooth. Meaning the DC is not as good as this normal DC. This DC is always constant 10 volts in one direction. This one is 10 volts in one direction, but it's from going from 0 to maximum to 0, 0 to maximum to 0. So whenever you rectify circuits like this, whenever we rectify circuits like this is what we say. Capacitor. A capacitor is used to store charges and smoothen. Anybody with a question? Anybody with a question on the smoothing?
لا لا مستر.
طيب الحاجة دي اسمها rectifier circuit. الحاجة دي جابوها في الامتحانات. You have to understand how it works. This is called smooth. Yes.
هنا الكارنت لما يجي تاني داخل كده مش هيمشي هيرجع بنفس الحتة اللي جا منها.
كيف يعني؟ قصدك شنو؟ من هنا امشي وين؟ اطلع
لا.
فوق كده؟ امشي وين طيب؟ من هنا؟ قول لي يمين شمال فوق تحت.
ما هو هيمشي كده، بس بعدين لما اجي راجع من الام كده هيمشي تاني نفس الدايركشن مش
كده من
يلا
وين؟
خليك
هنا؟
ستريت.
قلت لك الكارنت ما ممكن يمشي نفس الشارع اللي هو جاء منه. الشارع ده مشغول في الكترونز ماشيه كده، فعشان كده the current اوتوماتيكلي هيتفتش لشارع هو اصلا ما مرق فيه. اوكي
تمام.
بعدين شوف الكارنت دي ماشيه على النيجاتيف، so they cannot be attracted من positive, they cannot go back to the positive. هو اصلا ما في حاجه بتجيبه بجاي، ما في حاجه بتجيبه بجاي هنا بوزيتيف. اوكي ما ممكن يرجع لبوزيتيف.
صح got it.
طيب now a capacitor is a device that is used to smoothen or to store these charges. Ryan, do you understand what she just asked? She's asking if the current is passing like this, why does it not go straight? Okay, why does it have to go up and then go back? So I'm like, current will flow from positive to negative. It cannot go back to the positive. That's why when it passes here, once it takes this turn, it will look for a path to the negative, not back to the positive. Okay, for the point here is at any time the current will always be going from top to bottom here. It always be going from top to bottom. Now this is called a full wave rectification. This is called a full wave rectification. This is an example of a rectifier circuit. Sometimes you can have AC. Look at this motor. You have AC flowing through it like this, and you want to rectify it, but this time instead of using two diodes, you are using only one diode. Assume there's someone who's only using one diode. We said a diode is used to change AC to DC. So this is my motor here. طيب. So yes. طيب. So we are saying, let's try to trace the path of the current. Let's try to trace the path of the current here. So first thing, طيب sorry يا شباب, if you can just go. So let's assume the current here is positive and this is negative. Let's assume this is positive and the other one is negative. Okay, so what will happen? The current will flow normally from positive like this. It will flow through the motor and come back to the negative. So this will be like this. That's the first half. Now, in the second half, when the current changes direction, because we said AC changes direction, where this is negative and this is positive, do you think current will flow, ya Faris?
لا لا يا مستر.
The current will not flow لأنه the diode is reverse biased. So this second half will not be there. This second half will not be there. Instead, this time, there's no current that will even flow. The current will completely be stopped. And then from there, it continues. It flows again, and then it stops for some time. So this is called half-wave rectification, right? And it wastes this, so rectification using one diode wastes half of the power. فهمتوا يا شباب؟
أيوة.
So that's all about the special circuits. That's all about the special circuits. You have LDRs and thermistors وعندك diodes. السؤال ده أنا حاسة وسعت فيه. The only reason I've gone too deep is because there's one question that have been shown by Rinad in 2023 October November. So I think maybe we were not careful. Like it is part of your syllabus that you understand this. So it is part of your syllabus that you understand this. في زول ما فاهم الحاجة دي؟
فاهمين يا مستر.
طيب نحن فضل لنا شنو؟ We are left with some stupid stuff about safety. ما بعرف don't use electricity, water and dangerous electrocution and stuff like that. That's the last chapter. And the functions of a fuse and where a fuse should be connected. I'm just gonna send notes on that, and inshallah I'm also gonna send you a recording of me solving some questions. We've already been solving some questions together. Like I expect you now to be able to solve. Remember this worksheet I sent you. I expect you to be able to solve each and everything here now. All electrostatics, electricity, everything here. Whether it is talking about circuits, parallel series, you should be able to answer this. So Kida, I think we are done with electricity. So the next major chapter we will do will be waves. Now, Shabab, I want you to know that I will do waves to some seriousness, just like all the other chapters. Like in the beginning chapters, mostly we will do it using بنعملها using revision by revising from past papers. فهمتوا يا شباب؟
معلش يا مستر، لكن لشنو؟
شنو؟
لشنو ما حنقرا عادي؟ لشنو نعمل لها ريفيجن باي باست بيبرز؟
لا يعني مثلا انت عندك chapter 1 ده خليه. You have forces and motion graphs. Okay. وعندك غيره momentum.
ايوه.
وعندك moments. وعندك energy work and power. مش كده؟
ايوه.
Now these are, and then you have hooks law, springs, نسيتها. All these are called forces يا شباب. All these questions, inshallah paper 4, inshallah paper 2. In paper 2 they only bring around 5 questions من الحاجات اللي أنا قلتها دي. And in paper 4 they will only choose one and energy work and power. لو بالغوا شديد من ال10 أسئلة اللي هتجي هم هيختاروا من الحاجة دي كلها هيختاروا واحد. فأنا I don't always give preference لما أكون جنب الامتحان. I don't give preference to general physics. مش ما بعملها. لكن if you are to revise أكيد هيجيك سؤال من energy work and power. أكيد هيجيك سؤال من thermal physics. أكيد هيجيك سؤال من waves وإلكتريسيتي لازم ومagnetism لازم وatomic physics لازم وحاسة space physics كله لازم. لكن general physics الحاجات الكثيرة دي هم هيمسكوا منها حاجات معينة. ولو بالغوا شديد they're gonna take 2 or 3 questions. طيب فهمت يا فارس؟
ايوه فهمت يا مستر.
So it's about maximizing. It's about maximizing what will be tested first. If I was to مثلا tell you a series of questions من أي exam يعني. If I was to just give you a sample from any exam, لو فتحت 2022 مثلا أكتوبر نوفمبر فتحته question 1 جاءت energy work and power. question 2 جاءت springs. question 3 جاءت اسمها شنو؟ question 3 جاءت أكسلو. Now the rest from question 4 up to question 9, these are how many questions? 6 questions. كلها جاءت من الشابترز اللي انت متوقعها دي. And in order thermal physics أول، بعديه waves، بعديها electricity، بعديها magnetism، and then again electricity and then nuclear physics اللي هي atomic physics. So I think we should be maximizing in that. فهمت يا فارس؟
اي فهمت يا مستر.
You
طيب يا
open any
مستر.
multiple choice يا شباب, you can go and confirm that. ها؟
مستر احنا على فكره عندنا نشتغل حصه واحده في الاسبوع بس.
قلت كيف؟
قلت لك يا مستر احنا قاعدين نشتغل حصه واحده في الاسبوع بس، فانا حاسس ان احنا ماشيين بطيئين شديد يعني.
والله يا فارس كلامك صح. We are going extremely slow and I'm well aware of that. From the beginning of Ramadan, you will be joining lessons مع class, which inshallah by then I think we'll be having more revision classes. احتمال الناس تكون شوية أكتر من ديل. You might be like 20, لكن we'll be doing a more intensive revision than this. فإن شاء الله طمن يعني.
لا ان شاء الله خير.
احتمال بس بجر الويبس شويه، لكن بعد الويبس الباقي كله ان شاء الله you will do it as مراجعات طويله ان شاء الله.
ان شاء الله. اوكي يا مستر. شكرا.
طيب يا شباب I think we will stop there for today and then ان شاء الله we meet probably next lesson. برسل لكم ان شاء الله جدول بتاعت رمضان. How we gonna be having lessons in Ramadan with the class.
Okay.
يلا مع السلامه.